Now, in what situation would you decrease your estimate of the probability that the stock market will crash? Well, you would do that when um, you find some evidence that against the probability, if you find some if you find some evidence against the hypothesis that the stock market will crash. So we've got if we look at Bayes' theorem, we try to put in the values. We have to first decide what our H and what our E is. So here you can see that the Alex has always thought about the probability that there will be a stock market crash, and it talks about the hypothesis that the stock market will crash. So Alex is thinking about the probability that the stock market crash, and it talks about recent observations of stock market jitters. And if you read this, you'll hopefully come to the conclusion that the hypothesis is this one, the stock market will crash, and the potential evidence for or against that is our stock market jitters. So H is, we know what H is and we know what E is. And okay, well we know what H and E is, but we don't know what the probability of those things are. Although if we read through, we can see the probability of H given E, or sorry, the probability of H given E is around 0.2, the probability of E given H is 0.4, and at the beginning we're told the probability that there will be Alex thinks there'll be a stock market crash is around 0.2. Now that's before we've mentioned evidence. So I would say it's fair to say the probability of the stock market will crash in Alex's mind is 0.2. And that's what the first sentence says. But we still don't know P of E, the probability of observing stock market jitters. That's a problem. But wait, there's a trick to this. Because we know P of H equals 0.2, and we know PH of E equals 0.2, we know they equal the same thing. They're the same. Even after the stock market jitters have been observed, Alex's hypothesis, the probability in her mind, the probability of a stock market crash even after stock market jitters have been observed is still 0.2. So which means the evidence is neither for nor against the hypothesis, and the posterior is equal to the prior. Which means the answer is that Alex shouldn't update her estimate of the probability of a stock market crash. Okay, so again, pause the video, read the question, have a quick go at it. Now this question is pretty tricky. Fortunately, we're told what the hypothesis is, and that is Yixin will spend the weekend outdoors. And if that's his hypothesis, it sounds like the evidence that Luke plans to use is what he hears Yixin say. Problem is, he doesn't know what Yixin has said. So obviously the problem has something to do with the evidence. So we'll look through these our options for our answers, and we'll assess them one by one. Now I'm going to start from the bottom, from D. The problem here is that Luke hasn't identified a hypothesis that rules out either of the things he might have heard. It's quite possible that Yixin will be cleaning his kayak. Excuse me. That's not right because, I mean, although it's it's true, we already know what Luke's hypothesis is, so it doesn't really, it's just not relevant. There are alternative hypotheses, but we're interested in one hypothesis. And you'll see this if you try and assign meanings and put the relevant bits into Bayes' equation. You won't be able to put the numbers in there, but you will be able to put in values for H and E. Or can you? And that's where the answer of the question starts to appear, because you can't give a value to E because Luke doesn't know what he heard. There's no concrete observation here, which is kind of why C is a tempting answer. It's very appealing, but we'll keep moving on. We'll look at B. Now B says that Luke can't assign P of H any value as a prior probability. That's not true. He comes to this problem with no doubt some ideas about what Yixin is like and what she is likely to be doing that weekend. Even if he doesn't know Yixin, he can use other information. He can use his information about what the weather's like that weekend and where he lives in the world. What would a random person be doing on the weekend with what probability? You know, if you pick some random person off the street, what is the likelihood? What is the chance that they are doing something outside that weekend? And even if you don't know anything about the weather, you can just use an ignorant prior. Think of all the different things a person could do on a weekend and assign them all an equal probability, and so that among them they all sum up to 100% and go from there. Point is that B is not the correct answer. Now that leaves us with A. Now, A is the right answer, and it's the right answer because we aren't sure what E actually is, and that is how Bayes' theorem works. You have to actually observe E to be able to use it. You can, yeah, and E happening is not certain before you do your experiment or before you make your observations. That's why we're concerned with the probability of E. But after we observe E, we use that to update our prior and get a posterior. We cannot create a posterior unless we have observed some evidence. And knowing the probability of our observed evidence happening helps us to update our prior. Now, this is where it gets confusing, because after you have observed E, you might be tempted to think the probability of E happening is 100% because we have observed it, right? Try to bring your mind back to before you observed E. What is the probability of E happening before it has actually happened, right? Anyway, if you got this one, congratulations. It's a difficult one. If you didn't, that's fine. This is what we're here for. And I hope you're able to convince yourself of why A is the correct answer. Now this one is I'm going to say it's easy. Of course, pause, read the question, have a go. It's easy to understand once you understand. It's easy to get wrong, but it's also easy to understand. Sorry if you disagree with me. Hopefully I'll be able to explain it in such a way that you will end up agreeing with me. The first thing you've got to do is remember who Jean Nicod, or Nico, probably mispronouncing his name. Got to remember who he is. He is the guy that stated some criteria for evidence. And then Carl Hempel comes along and does some clever logician work on his criteria and turns it into a paradox. And that's the Raven paradox. But before Hempel comes along, Jean was all like, oh yeah, if we want to, well, in the case of eucalypts having sap-sucking insects, we just need to observe eucalypts with or without sap-sucking insects. If I'm going to say that every eucalypt has sap-sucking insects, the evidence for that claim would be observations of eucalypts with sap-sucking insects. Now, you have to consider what would evidence against that claim be. Now, what Jean was thinking was totally intuitive, and like it wasn't until Hempel came along that it was even a problem. I'm surprised. Sometimes it's hard to imagine why Jean felt he had to write it down because it feels kind of intuitive, right? If you have a hypothesis like our eucalypt one, then if you want to go support it, you go find observations that support it. And what's going to sort of be evidence against that is if you go find a eucalypt that doesn't have sap-sucking insects. And the same goes for the hypothesis that all ravens are black. We just go out and observe black ravens, and then we see a raven that's not black, and that's evidence against it. And obviously, that's evidence that's going to completely destroy our hypothesis, because if all ravens are black and we've just seen a non-black raven, well, so much for that hypothesis. You can say most ravens are black, and then we can still continue our work looking into the colors of ravens, but I digress. The thing that might have tripped people up here is that some of the options talk about non-eucalypts. Now, it wasn't until Hempel came along that non-eucalypts would have been considered. Like with the ravens example, he pointed out that by Jean's logic, or by Jean's criteria of evidence, you could observe non-ravens and have that count as evidence for or against the hypothesis that all ravens were black. Actually, I think non-ravens could still only count as evidence for the hypothesis that all ravens are black. If you wanted some evidence against that, you would need to still need to observe a non-black raven. In any case, the answer is D. Pause this one, have a go. My explanation is pretty simple. One of the important conditions for the wisdom of the crowd to work is independence. If the guesses of all the participants have been written on a blackboard for everyone to see, including the people that are going to enter the competition in the future, then the condition of independence is not met. And it says right here, I look at the blackboard and notice that 50 people have already entered, guessing everything from blah, 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 blah. Presumably all those 50 people also could see this blackboard, and there's no reason why they wouldn't have been able to. And even if they couldn't, if you can see it, then it's fair to assume that the others have. And you'd be a bit naive to think you're the only person that could see all this information. But having said that, it is a bit of a cheeky question. It's kind of like the trick is hidden in here. But like with all things, the devil is in the detail.